Hi everyone, welcome to the second part of our videos on ORE Studio. These videos are just sort of a basic overview. I guess we will start making videos, more specific videos with functionality within the application, I guess. So before we get into the video proper, in the previous part we had an issue which was, well, we had two issues really. We weren't able to submit any jobs to the compute, and we weren't able to see any counterparties. So I've tried to address those two issues. If you've looked at the pull requests of late, you may have seen a few. I mean, I haven't quite been as busy as usual, but managed to get a few pull requests in. Trying to address those issues, and we'll see if all the fixes have landed correctly. In reality, the main problem with the counterparties was that we were using the dataset large, which has got 15,000 counterparties, and that is slightly problematic because the way the system works at present is that we make a call to the database, which sets up the data from the data quality subsystem and copies that across over to the production, or to the party, should I say, tables. And because it's a lot of data, it takes a little while. So in fact, we had two issues really. First was that large was not really part of the data set, which was a bug. But then when I did add it to the data set, it resulted in this error that I described. So what we need to do is we need some kind of batching so that when we have too many rows, we provide some kind of feedback. And Claude has outlined an approach to fix this, but I decided to just, since I know what the problem is now, to just continue using the small dataset, which is what I always used. I'm not entirely sure why I decided to use the large for that particular example, and that's what caused the problem. So there was a number of issues really. We should have reported the error, which we didn't. We should have, well, it should have not been missing from the dataset, and so on. So I did a number of fixes with Claude. So what we'll do, and the second problem was, in fact, the second problem, I was looking at it just now. I am currently working on a pull request for this. Hopefully it's fixed, but I'm just about to test it, so I thought I'd write a video as I do the test, just to do two in one, I guess. But before we get into the nitty-gritty of the steps that we were doing previously, I thought I'll take this opportunity to just address a few topics. Since the last chat that we had, I created a new channel just for humans called Discussions. A number of people have contacted me either on LinkedIn or on direct messages in Discord or via Twitter and so on. And unfortunately, people are not really talking via the Discord, which would have been slightly better, I guess, for the community. But nonetheless, I will just address the comments and the criticism and so on this video. It's nothing particularly private of those questions or comments. So the first thing is, you may have noticed on the mailing list, Dimitri from MathLogica replied, and he made a comment regarding AAD. So MathLogica has got their own take on AAD, which is this AADC. Which Dimitri mentioned, and they've got very good documentation, and it's something that's in production. And I quite like their approach. So what I replied to Dimitri's email was, we are definitely very interested in AAD and AADC. For those not in the know, what AAD does is it enables you to, well, for a layperson, as a layperson sort of explanation, imagine that you've sliced the core parts of Quantlib and of ORE, just so that they have like just the computations, right? So a bit like a kernel, right? A GPU kernel sort of thing. It's not exactly that, but there's probably good intuition for it. And for Jorg's particular use case, what they do, and you could probably see a link here back to the chat I had with Jorg. I believe I added it, if not I forgot. There we are. So there are several ways in which you can do AAD. One is, which is the traditional AED, I guess, is the tape-based approach, in which you start to, you record a tape with the operations, and that tape then becomes sort of used, then it is then used to then run the calculations. I try not to make this a bit too technical, but this is kind of the gist of it. You create a tape. Imagine this is a two-step process. First you record. Once you've recorded, you can then replay many times. This is particularly useful for intraday use case, because as you can imagine, what tends to happen with the intraday population is, in a typical exotics derivative system, you tend to have a population of trades that's fairly stable. The part of the population that changes quite a lot tends to be spots and forwards, and those products are not particularly complicated to calculate. But on the more exotic side of things, those products are very stable. Maybe you'll enter a few trades a day, but not that many. So what's really, really expensive is when you are computing, you are recalculating risk for that stable population quite frequently, as many as, I don't know, every 5 minutes, every 15 minutes. Normally the approach you tend to take is you tend to split up your population depending on valuation times. So perhaps you could, the more vanilla stuff gets revalued every 5 minutes or every 10 minutes, but maybe the more exotic stuff gets revalued every 15 or every 30 minutes. And it's not because you don't want to recalculate the exotic stuff more frequently, it's just that computations on the exotic stuff take so long that you end up not able to, before the schedule for the next report is kicking in, you still haven't finished the previous one. And what you don't want to do is you don't want to go as slow as the slowest part of your population. So that'll be very bad, because you may have one or two deals that are very exotic and could take very, very long time to value, and you don't want your vanillas to then start taking a very long time because of the exotics. So what I've seen a lot in desks is that they tend to split the population according to these characteristics of valuation. And with AAD and AADC, not only the exotics cases but also the vanilla cases get all sped up, because these kernels are very, well, because this the valuation functions that are created using AAD tend to be extremely efficient, sort of 10 times or more efficient than a regular ORE sort of valuation. And of course you can imagine why that is. It's because QuantLib, whilst QuantLib is a great library, it's not really written for performance. It uses a sort of a OO approach, and if you were to write QuantLib in a more modern fashion, you would design it to be probably very GPU designed to fit very carefully the GPU model, so that you can do a lot of valuations simultaneously. So for instance, if you got 50 or 100 or 1,000 trades of the same deal type, you should be able to value those with very few passes. But in a ORE stroke QuantLib world, what you tend to do is you tend to recompute a lot. There's a lot of overhead that would be in a system that was designed differently and using data-oriented principles. You would probably have a lot less costs in setup costs and so on. But AED sort of compensates for that, because it's kind of the best of both worlds. You don't have to rewrite the entire code to use data-oriented approaches, which is not trivial. I've tried in the past writing codes using data-oriented approaches, and it's not super easy. It's actually quite complicated. If you are interested in that, I highly recommend the data-oriented book. I don't quite know what's going on here, but data-oriented programming book. I have read this book very carefully. It is actually free. No, I should have probably searched for this link before. No, this is actually a Manning version of a book. There is a sort of a free book. I'll put the links on the video. And here we go, data-oriented design. So there is a PDF. I'll just do data-oriented design. There's a PDF for this, which is free, by Richard Fabian, and I highly recommend this book. It's quite good. And if you I mean, I bought the Dead Tree, so I recommend buying the Dead Tree. It basically uses or describes the gaming community sort of approach to programming, which is very, very different from sort of the object-oriented approach that we take in quant-lib. But I'm sort of sidetracking myself here slightly. The gist of it, the part that is really important for us is having an AAD or some AAD-based methodology will be extremely useful because if you could value much more quickly, it means you can have a much more aggressive valuation schedule. That has huge amounts of advantages. For example, one advantage is that you can compute for intraday. So in a typical intraday scenario, one of the things we do a lot is we need to value not just your headline position, but you also need to do what's called the trade activity valuation. And the trade activity valuation is quite complicated because what you're trying to do is you've got an input stream coming in, and you're trying to understand of that input stream what is responsible for moving the P&L. So for example, you could have changes on different kinds of curves in market data. You could have changes within the trades themselves. There's always a passage of time. There's many trades which are non-linear, and it's important but difficult for the traders to try to understand what's causing their P&L to move. So the easiest way, or the most common way to try to calculate trade activity is to try to shift market data, or to try to build a market data environment which is fixed on all aspects which you're not particularly interested in. So for instance, let's say you're trying to evaluate what the impact of vols is. You could take two market data environments, one at T0 and one at T1, T0 and T1 being 2 time points, and then you could copy across all of the items of your market data environment from T0 to T1, with the exception of, say, your vol surface. And even in the vol surface, you could probably say you only want the riskies, or only want the strangles, and so on. And then what you do is you value your prey population with both T0 and T1 market data environments. And the difference between the two, the delta of the valuations, then becomes the impact of the curves. Now, as you can imagine, there's many inputs, and because you need to do this in a granular manner, there's many valuations you need to do, and which then, in a normal sort of hedge fund stroke investment bank environment, means that there's very high cost in the compute because you're computing a lot. So the option normally tends to be to try to schedule your trade activity runs a bit slower, so that you can save a little bit on the compute. But there's a trade-off there because, there's a reason why you want to know what's bumping, what's changing your NPV, is because you need to see where the market is going and see what kind of hedges you need to do. So if you just run this once an hour, that will be very bad, because it's a bit like driving blind for an hour, right? So what you really want to do is you want this to be very frequent. In fact, ideally, you want it to be event-driven. You can't be completely event-driven, as you can imagine, because of course spot is ticking very frequently, and other things will tick quite quickly as well. But you want it, think of it as the limit of the function. You want it to be as much as possible event-driven. Then you start to do trade-offs, right? And then maybe you can say, okay, fine, maybe I won't tick it with every single event, maybe I'll batch a few events together. But you certainly don't want the interval between T0 and T1 to be too big, because otherwise, as I say, you're driving blind. Anyway, all of this to say, if you are trying to satisfy an intraday use case, which is very different from the end of day use case, for which ORE is probably more than sufficient, because in the end of day use case, you've got a number of reports, your XVAs, your VARs, and so on. And those reports could just run overnight. So you've got 8 hours, you've got an 8-hour window. You can run these reports, and then once it's finished, it's finished. You may have 20 or 30 reports that evaluate different aspects of market risk, credit risk, and so on. And those things run overnight. So for intraday, for end of day, AED is useful, of course. No one wants to pay more for the compute than you need to, but it's slightly less critical, I'd say, than it is with end of day, intraday. Because in intraday, time is really, really important. You want these things to run as quickly as possible in order to be able to actually respond to market events. Very, very long preamble, but you can see why we are extremely keen on having AAD integration. Now, with all of this context, you hopefully will understand a bit more what my reply to Dmitry was about. So, with Jörg's approach, it is up to us to integrate QuantLib AAD with ORE. In theory, there is nothing sort of stopping you from doing this. QuantLib AAD, it's got exactly the same interface. What it does is, because QuantLib is very cleverly written, it enables you to redefine some types. And that redefinition of the types enables you to perform the computations required to create the tape without changing the interface of QuantLib. So in theory, theoretically, it would be possible for you to just try to make a build of ORE using QuantLib AAD. You'd probably find that the tape generation will be quite slow, as expected. But in theory, it should be a fairly straightforward exercise. However, in practice, what my conversation with Jörg revealed was that you do need to spend a little bit of time going through the different reports and the different measures and so on, and see how exactly they perform. Because there are limitations to AAD in certain cases where AAD doesn't quite work the way you'd expect. And so it's probably not wise to just create super complicated reports and then try to see if that just works out of the box. You probably need to start building it up slowly. Maybe you start with NPVs, then you start with deltas and so on. And maybe you don't start with every single trait type, maybe you start with certain trait types. There is an analysis work that's required and an implementation work as well. So I just put this task on the backlog. You may find this in our product backlog. However, so that's sort of good news, but mid, I guess, because we haven't got time at present to spend time doing the integration for QuantLib AAD, which will be extraordinarily useful, but it would just divert our efforts, and we have a lot of work at the moment on the framework itself. So Dimitri's alternative is quite interesting because what Dimitri has done already, from what I understood and from reading the documents that he linked here, which I recommend you to have a read, there is already some kind of ORE AAD binary which integrates seamlessly with ORE Studio. And that being the case, in theory, you don't actually need to do any work on our side. If this is what my ideal scenario would have been for AAD, really. Because, again, I'm not a quant, so I don't really understand completely the maths around this. I think it would be not best use of my time to try to get too much into the weeds of this. I prefer a black box that I could just use and test, which seems to be what QuantLib ORE plus AADC presents. So I am trying to catch up with Dimitri at some point, as it happens. So we're not far from each other locally. So I will play around with the tech. We'll have a chat about this, and if it works the way I expected, it will be really, really useful, because it won't require too much work on my side. So that is the AAD conversation that was going on in the mailing list. Again, I haven't received too many replies to my posts directly on the mailing list. It's been mainly direct contacts from people. I'm not sure if they would like me to mention. I'm just mentioning people that have contacted me publicly. Otherwise, I'll just make a reference to the comments or things that have been said. So the other thing that was asked as well was about general questions about the stability and maturity of ORE Studio, which hopefully I've replied both in my tweets and my posts on LinkedIn. I don't want to give any false impressions to anyone. This is a very alpha project. Pretty much nothing works properly at the moment. It's still very early stages. I suspect we need another 5 or 6 releases to get something half decent working. But as I said in the previous video, my hand was slightly forced because I am keen, as I tend to do every year, I'm keen to go to the ORE Users Conference, which will happen on the 11th of May. I still haven't got my confirm. I'm hoping that I will be able to attend. And I just wanted to share this with people to get exactly this feedback that I'm getting, so that we can, so that more people know about it, and more people will hopefully want to talk to me when I go to London for the conference. So there's that. What else do we have on our list? Another problem that we had as well was our Windows builds have been broken for a while. We're not completely out of the woods yet with Windows, I don't think, but it should at least build. So some of you have been trying to build and complained that you had problems. I apologize for that, but unfortunately, similar to AAD, we also have a computation problem in a way, because I can't install PRs by building every single operative system, even with C cache or SCS cache or whatever it is that we're using now. It still takes too long. Like as you can see here, this is a long build. Sometimes we touch something on VC package and it takes forever. So what we're doing is to make our life easier. We only build a canary build, which is just Linux, and then when you merge the master, then we trigger the build across all the operative systems. Also, I don't personally use either OS X or Windows, so I'm kind of trusting that this build is green and the tests are passing. But it would be nice if people that use those operative systems in anger actually do builds and check the results and make sure everything is as expected. That means that it's quite frequent that we break, especially the Windows build. At present, the main problem is that we have libraries that are very large. For example, trading is quite large. We need to start splitting this into slightly more fine-grained components, and that's bursting all sorts of limits on Windows. That's one reason why we always wanted cross-platform, is because it's another way to get some data points as to when you make mistakes with the architecture, even if we don't use Windows, because in a way, Windows limitations end up giving you a good feedback. Like for instance, you're making a component too large, or for instance, you're exporting symbols that you shouldn't, or you're not exporting symbols that you should. That's another common problem we always have. And that causes the Windows build to break, and with that we tend to find issues that we then fix. So that's that on Windows. As you can see here, it's looking a little bit green at the moment. Okay, so I think that's all we've got for the laundry list of things to tackle. So what have we done? We just did a database reset. We did a build that took a little bit of time. Another problem I've got is, unfortunately, my RAM. I only have 32 gigs of RAM. I used to have 64, but for some reason 2 DIMMs just died, which means I'm now running only 4 compilation jobs at the same time. And because the project is getting larger and larger, it's taking longer and longer to build. As you can see here, this build took 41 minutes, which is a long time. And I can't, like I used to before, I used to run lots of compilations at the same time. And now I have to serialize the compilations across Claudes, which has slowed me down considerably. Unfortunately, because the RAM is quite expensive at present, I can't really go and buy more RAM to replace the DIMMs that were broken. So we'll have to live with it as it is at the moment. At any rate, we just did a complete new build. We picked up latest VC package recently, because I just, oh, actually another thing I should probably mention. I just did a release, as I think I mentioned in a previous video. When we gather enough commits as per our commit since badge, we just create a release. The process of releases is more or less automated now. We've got some skills that generate the release notes. Basically, all the PRs from the previous release closure contribute towards this release notes. I was struggling a bit. So in the past, we had nice little org mode based release overviews up to release 15, 0.015, and that was quite nice because we used to manage the time manually. As you can see here, I used to manually follow stories and so on. But what I've noticed is, maybe a few releases ago really, it has been a bit problematic to do clocking properly. The reason being that I now work with 3 Claudes sometimes, and it's very difficult to attribute time properly. Once you got 2 or 3 stories on the go at the same time, sometimes I could have a story that's very long, but I've actually mainly waited for Claude, and I could have a story that's very short, but I've actually spent a lot of time going backwards and forwards with Claude. So anyway, the clocking was not really reflecting effort. So this sprint, we tried something different, which is we stopped clocking altogether, and we just asked Claude to estimate how much time was spent in the stories. Now, we also accumulated a lot of PRs. This is a bit too much. We normally don't want much more than 70 hours worth of effort, which, again, we can't really measure very well. But anyway, we don't want too many PRs. This is probably like twice as many PRs as we would like in a release. And this is probably an exaggeration from Claude, but I suspect not by much. Probably 120 hours maybe in the sprint. We probably want 70 really. Okay, all of this to say, this was a bit of a special release, and the release notes are not the cleanest. We're still playing with this. What we don't want is to spend too much time playing with release notes and so on. I want to spend more time focusing on coding. So the key thing of the release notes is to allow me to be able to say, okay, whatever we've been working on for the last couple of weeks, or last week or so, and just very quickly see what's going on. So for instance, if I just have a quick look at this release, you can see here that we worked on this workflow service. The idea with the workflow service is last sprint we finally hit an issue, which is we didn't really want multi-step processes that involve calls to multiple services. We didn't really want that to be owned by one of the services. As an example, ORE XML imports that involves going to the storage service, downloading the data, converting the XML into our domain types, then taking those domain types, converting those to well, actually, before you do that, you need to convert those to our representation of our ORE types, which we generate using XSDCPP. Then once that's done, then we do mapping into our domain types. And then once the mapping is done, we can then use the repositories to push the data to the database. Now, this involves calls to multiple services. And in the past, we had to decide where to put this logic. And the logic was just placed somewhat arbitrarily on ORE service. In reality, what you really want is some orchestration service, which we called workflow, which is not really, I mean, as would probably anyone who's worked in a real trading system, the word workflow probably brings you PSTD, because everyone is probably familiar with workflow engines and all sorts of madness that we all worked in the past. And that normally there isn't very good options. You either use a workflow engine that already exists, like the one from Microsoft in C#, or you create your own, but either way you end up with very, very large code bases that require a lot of ceremony. So our workflow at the moment is really, really simple. It doesn't do anything too complicated. It just keeps track of the steps, and it tells each service to do their bit. I try to make it as simple as possible. I mean, as much as you can. After all, workflows is a complex topic, but the idea was to keep it as simple as possible. And we use the workflow engine to implement ORE integration. I will do a quick demo in a second of how this works. It's still very early days with this, and it's still not perfect, but it's just we're slowly moving towards it. We've also added a few domain types. This other step here is the actual integration with round trips for the instruments, which we're testing at present. We started working on the market data types. We tried to clean up a little bit the database model. I tried to do this in steps. I'm not sure if this was the right approach, really. I tried to do, in the beginning, I did a very quick import of all the domain types. I just told Claude to do something simple that enabled me to put everything in the database. But then once that was in, I started noticing a lot of problems with the types. So we did a series of refactorings. and we are still refactoring. I don't think that the current model is very good, so we're still working on that. And the other thing we had to do, as I mentioned before, because of Windows, we needed to split the monolithic Qt binary into plugins, because the app was becoming so large that it was struggling on Windows, which is a good thing. That's exactly what you want. It's telling you of problems. So now we have plugins that are using a regular plugin interface, and each of them are focused in a component of the system. And then the release, if you're interested, you can then read the release notes. It gives you more detail about these tasks. So that was the release that we just did. That was 3 days ago. Okay, so I think that's all the laundry that we needed to address. We can now think about the actual demo. So what we've done is we've actually what I'll do as well is let me just start with another client here, just so we can have 2 clients. We can always tell the release, as you see now on the splash screen, but we can also do about. This will tell you what release we're in, just here, 17, and it tells you the commit as well. The dirty just says that there's some data which is not being committed yet. So what we'll do then is we will just do the usual login. Fortunately, these videos are quite long. Hopefully, we can make more focused videos in the future. As you can see here, we're logged in. Actually, part of the work that we just did has to do with fixing the URL that we had as an issue. So let's ask Claude, can you please check the logs to make sure the HTTP URL is populated on login. Claude, unfortunately, has to be not very good at remembering things, so it's probably better to just tell it where the logs are. We'll just ask it to go to the publish directory and then log. Is this directory here? We can just tell Claude logs are in.
Very well.
So Claude will go and do his thing. We need to set up our system, like I say, create accounts, we create just a tenant. I mean, you could put whatever you want as your tenant really, but for whatever reason we started off by using Barclays. And I've set it up so to make my life easier.
All done.
Okay, Claude seems to think he's found something. Okay, so with this we have finished provisioning. Let's see what Claude says. Okay, that's good. So Claude thinks that the URL is available. So let's just have a quick look at how the system looks like. Interesting. Okay, that's interesting. We didn't really do anything particular to the compute node, so
right away.
It's quite interesting. I mean, of course, these days of AI, one tends not to do very many things by hand, but you do have logs, and you can open the logs and see. Hopefully, the logs are verbose enough that they tell you what's going on. So I suspect what's happening. Let me just, before we get Claude to do too much work here, what we'll do is I'm just going to disconnect. I don't even need to restart the UI. Just going to disconnect, and we're not connected here anyway. So I'll just disconnect and I'll just stop services and then start services, because what I did a second ago was I did, as I mentioned in the previous video, we have these scripts to recreate the database, and I just ran these scripts, and I'm not sure if I was running the scripts with the services already running. And our services are not exactly the most resilient at present. The retry logic on the connection is not great. So let's just double check that was not why. So we'll just reconnect and then see how the services look like. No, it still seems to be down. Restarted services. Still not down.
Right away.
So Claude will go and investigate this. You can see here the error seems to be a bit obvious. Some kind of issue with NATs, I think. We seem not to be able to open up a stream with JetStream probably. So hopefully Claude can address that while we are working. The rest of the services look green. One thing you can do, I haven't demoed this before, but see if I remember how to do this. There was a way. Oh yes, you double click on it. So if you double click on the service, it tells you what the service thinks is doing, and it shows you the log file here. So you don't have to manually go to the logs. You can see here. You can see the errors. It gives you as much information as we can, including the command line. This enables you, if you want.
We have a problem.
Okay, Claude seems to be upset.
We have a problem.
Let's just double check. Claude is not remembering that we need to use our nats config, and also you are in the sandbox. I've started playing around with sandboxes and it's useful, but unfortunately you do tend to have a lot of rather annoying errors with sandboxes. Okay, so that is, I think this is actually quite useful. Interestingly enough, we also seem to have more than the... Okay, we just found a bug with our little orchestration, service orchestration with the controller. It started more than one replica. The reason why this is happening is because I think when I did my stop, I don't think I stopped the services properly. So if you got two replicas, that's not a good sign. We should only be starting one replica. So as I say, there's quite a lot of bits and pieces in the system that are not working perfectly. In fact, that also means perhaps our restart was not a real restart.
Task complete.
Can you run the command?
Very well.
Okay, so it is, according to what Claude is telling us, it seems like our stream...
Something's not quite right.
We renamed recently the streams, and you can see the streams by going to system telemetry, no, message queue actually. You can see what you've got available in NATs. As you can see here, you seem to have two streams. This is the legacy name, which I didn't really like. And we have a new name, which is lowercase. But I think there's some confusion as to what the real name should be. So that's the word.
Finished. Anything else?
Okay, I think Claude...
Very well.
Claude forgets quite a lot that he's in the sandbox, so a lot of times he runs a command and then is surprised and thinks that things are not running when they're actually running. It's just to do with the sandbox hiding things. I must say I'm not entirely happy with the way sandboxes work with Claude. In fact, this video is going to be quite large. So how long have we been running this for? What is the time? 39 minutes. Okay, I think we might have to... we'll just dedicate this video to addressing our issues here. Let's kill all services. I suspect, oh no, actually this seems to have worked. So I'm just going to disconnect for a second. Okay, and then we'll reconnect. Okay. We'll probably just say, can you check the services will stop? Just because I am a bit surprised that our restarting the services didn't really work properly a second ago. Fortunately, we have a lot of things with ORE Studio in the name. So we need to grab twice. Okay, so that looks slightly cleaner actually. Okay, that looks cleaner. I'll just wait for a second to make sure Claude is happy. This was not my intention, but I think this is a good way to also get users or developers more familiar with the system. So all these problems tend to be quite illustrative of how the system works. So I think that's a good thing. So hopefully Claude is going to be happy in a minute, and we will be able to connect. I don't really want this video to be longer than an hour, so what we'll do is we'll just focus on this particular problem, and then once we get to around an hour, and then we will create another video dedicated to something a bit more useful. Claude is taking his time. Didn't think this was that complicated. So whilst Claude is doing his thing, maybe what we can do is I'm just going to quickly show you some of the services here. So we have services like IAM just like IAM in GCP. It provides everything to its security. You will not fail to notice that we are logging at the moment a private key. This is not great. We are doing a number of things, a number of silly things like that. What Reflect C++, we use, actually I didn't mention this before and I probably should. We use two technologies quite a lot, which I'd like to mention because they are really, really useful. They are from this company called GetML, which I quite like, and they have a very great developer behind them.
Yes?
Okay, Claude seems to be finished. No, it's just asking for some permission. So Reflect C++ is one of the technologies we use a lot. It's good because it's just a series of annotations or well, very simple changes you can make to a struct, and it enables you to then obtain serialization code. Obtain serialization code for the types. Okay, it seems to be happy now. With very little changes on our side, and also it gives you very good JSON support, which we like quite a lot. We like JSON support because it's good to log stuff to the log file like this, and then using Emacs I can then do things, and this is one reason why I have not removed sensitive stuff yet, because I can then use some of my Emacs wrappers or functions to make my life easier. So I can go to any log line that's been dumped in JSON, I can format it nicely, and very quickly I can see what's going on. And for the key, for example, whilst we were still testing, it was very useful to have the key here because when there are issues and so on, I can just faff around with it directly. I can validate the key in OpenSSL. I've got other scripts that do translation of things to the new line and so on, which make my life easier. So that's that on logging. I try to keep the logs as clean as possible for two reasons. First, because I use the logs quite a lot, and second, because Claude uses the logs quite a lot. So we log extensively some things at trace level, some things info. We do tend to be quite careful, I think, about logging, and we do log a lot. So one day, once the system becomes a bit more productionized, we will probably start using log level info. But for now, we are logging at trace and seeing everything coming across. So Claude is done, so we're not going to spend any more time on that. We'll continue. What we'll do is we'll just quickly connect again. And then we will go back to our, well, let's have a look at the queues. These menus are obviously not the greatest at the moment, but this is something else for the future. So as you can see here, we have the workflow queue and we have the compute queue. So that looks good. If I go to the service dashboard, it looks a bit healthier now. You can see that the stray replicas are gone. Interestingly enough, you're not able to open a service unless there's an error. I think we should always be able to, since it's useful. Sometimes you want to see the command line, for example, or just the log. And you can see that the compute wrapper, all the nodes have started correctly. It is interesting you have 6 restarts. I think this is counting the restarts since the previous run. So that's fine. Okay, so we seem to have done all right with this. So we will go to the other window. We see we're using red here, and then we will log in. In this window, we will quickly just log in into our tenants. Now we'll be slightly more careful with our tenant, just so we can see that issue with the counterparties that we mentioned before. So whilst that's doing its thing, we will just see if there's anything else we could see. Some functionality here is not functioning particularly well at the moment. For example, I haven't tested log viewer since we moved to NAT, so I'm not sure if that's working correctly. We do have a console. It was quite useful at the start. It's a bit not very well maintained of late. As you can see, it gives you a number of commands here. So for instance, if I do, I don't know, let's say tenants get, for instance, it gives me the tenants in the system and so on. I mainly designed the console because I wanted a way to quickly interact with the system via the shell, and I used to use it from Emacs a lot. But then with AI, I have actually used it a lot less now. But what will happen in the future is we will probably export some MCP interface so that AI can interface directly with the system. That will be something that we will do once we're in a good place. The console is still using the legacy approach, which is not connecting to the services, it's actually writing directly to the database, and that's not ideal. Okay, we seem to have finished. Okay, so now we will just be very careful here. So we should not use the large data set. And then, oh, this is actually just the parties part, not the counterparties, so that should be fine. Okay, so this, as I mentioned in the previous video, initializes the house of the system, and because this is a multi-party system, the house is effectively all companies within the group. So and this is one reason why we use Glaive. So we have every single party within every group that you choose, well, within the data set, the sample data that we've got. So you, the main reason why we do that is because we wanted to test multi-party to make sure multi-party was working correctly. It does have the slight disadvantage that it's a bit slower, because as you can imagine, Barclays is not exactly a small group. Also, I'm sure there's a lot of things that could be optimized. I'm sure there's a lot of slowness due to the way we're doing things at present. Once we finished feature-wise, we then need to do a big revision of the code to check to see that if we're using Postgres correctly and so on. The first objective is just to get everything to work end to end. This is taking a little while. Okay, so according to this, it's because in addition to publishing Glaive, it's also publishing everything else on the datasets. Okay, so at this point in time, we are connected to the tenants, and the tenant has been initialized. So what we'll do is we'll disconnect to the tenants because we logged into the system party, as you can see here. So we will log in again. And once you try to log in again, as we mentioned before, it will force you to choose a party because this user now is assigned to more than one party. So we'll choose the root of the group. Now, because this party has not been initialized, it will also go to its wizard. This is what I was trying to say before. You need to use a small data set because at present the large data set is not really working. It is too large and it's timing out because Nats has a limit on the timeouts, and because of the way we've done it, it's a single operation in the database for the entire data set, which is obviously not ideal. What we should have done is we should have done it in blocks. So we should have done a few parties, maybe split the 15,000 into batches of 5,000 or something, and then get a knack per batch or something like that. We have not done that, so because of that, it times out. You can see here, it's 6 or 5,000, whatever the size is, of small, is still quite slow. So imagine the 15. And up to now, we've sort of hacked. What we've done is we manually set the timeout for things that we think take too long to be a bit longer, which is obviously a very big hack. And unfortunately, I've done quite a few hacks like this because the problem with creating a system from scratch is that there is just so much stuff to do and there's so many possibilities that you could literally be working on it forever. So sometimes you just have to move on to the next thing and then backlog things. And that's another reason why if you go to, while we wait for this, if you just go here to, you just go to Ora Studio and look for doc. You'll see under the Agile folder, you see a very, ever-growing product backlog, which contains, many things. It's just basically every time we bump into a limitation, we just write it down, or Claude writes it down for us anyway. Oh, actually, I was in the middle of saying something and then I interrupted myself. So, as I said, the GetML guys do some interesting C++ tech. Reflex C++ is one of them. We use it quite a lot. And the second one is SQL Gen. So, most of our stuff to connect to the database uses SQL Gen, which uses Reflex C++. This makes our the code that we need to write for the database integration and serialization very, very easy. And this chap is very, very responsive. We've done a number of pull requests. If you look here at close pull requests, you'll see there's a number of pull requests that I've done, and they've been looked at very quickly. So I have nothing but good things to say about Reflex C++ and SQL Gen. Of course, we haven't sort of done things like timings, and we haven't tested performance in anger. I can't say I found a problem with it yet, but I haven't validated the performance, so I'm not sure if using role libpq is not faster. But since GetML is a machine learning company, since they also focus a lot on performance, I suspect their code is probably fairly efficient. Okay, now we've done that, and I'm just going to start closing some tabs, just so I know what we've already spoke about. Let's see how long we. Okay, we are reaching an hour, so we'll finish this video soon. So hopefully, okay, we have finished. So we'll just generate all the reports as we did previously. This should not take too long because it's just the report definitions. So just to recap then, the system works in sort of several layers of, I was going to call it abstraction, but it's not quite the right word. Isolation, I think. So you have a system. Within a system, you can have multiple tenants. Within a tenant, you can have multiple parties. As a user, you log into a party and a tenant, because a party belongs to a tenant, so you can't avoid that. When you log into the system for the first time, you need to bootstrap the system. When you log into the tenant for the first time, you need to bootstrap the tenant. And when you log into the party for the first time, you need to bootstrap the party, which is what we just did. Once you finish bootstrapping the party is ready to be used. So the two things we will check very quickly is we will just double check that parties and counterparties look healthy. So as you can see here, these are the parties. I must say that we have some kind of issue with Unicode. I'm not sure if this is a cute problem, but we have parties that are coming from Glyph using Unicode characters, which don't appear to be rendering correctly. Not entirely sure why, but again, sometimes we do render them correctly, so we don't have the time to look into all these issues. Perhaps when we have international users, they could look into it. So you can see here, these are the houses that we've got. In other words, the parties which you can trade. There's the system party, which is a special party, and then there are all the other the other parties. We're currently logged in to Barclays PLC party, which is this chap here, and we have all these other parties here which we can generate trades against. So that solved that problem, and then I think just to double check that we solved our compute issues, because we got about 5 minutes in this video, what I'll do is I will attempt to submit our test job once more. So I'll just go to the compute console. In the apps, I need to upload the binary. Now these packages, these are ORE Studio packages, they're not particularly complex. I'll show you the contents of the package in a minute, which also links back to the ORE AAD conversation we had at the start. So if I just go to external, ORE, and packages, here you can see the package, and I'll just click here. And then if all has gone well, you can see the package has been uploaded. So I'll just close that. I'd like to see, so you see we still have some bugs here because that package upload, I believe, was a workflow, I think. No, it is the workflow, okay. But provisioning parties is a workflow, so I think we should have had an entry here. So there's something not quite right with our dashboard yet. We were testing this in the last spring. At any rate, what was I saying? So I've done the upload of the package, and then what I can now do is I can create a work unit for it. So I'll just right. So I think we don't have a batch. That's why. So let me just close this for a second. So I'm just going to create a batch called test. Doesn't have to be particularly special. So this will go away, and now hopefully we'll have a batch, we'll have a version, and we have a sample that we got here. Again, I'll show you what's in these files in a second. And we don't need a config file, so that's probably about it. So I'm just going to submit this. Let's use the new record. So this is going to go away now, and if all goes according to plan, it's taking longer than expected, so I think things are not going according to plan. Yes, as you can see here, we already have a bug. Oh, okay, maybe I was underestimating myself. So that seems to have worked. It's executed on this host, bumbling D-hole, whatever that means. So we could just have a quick look at the details of this task. That seems to have done a few steps here. Just running ORE, and not much more can be told from here. Because none of this is integrated properly, what you need to do at present is you need to download what the node has produced, which is basically a tarball, and then once this is done, it's actually should have been slightly quicker than that, given this is very small. Not sure why so slow. Again, performance has not been an issue, or well, not one of the dimensions we've been optimizing for. We will worry about that later on. I mean, we're not trying to do things slow on purpose, but so let's have a quick look at what these files look like. So Emacs is opening the tarball and compressing it and providing us a view of the archive. This is again horrendously slow for a 42 KB file. I'm not sure why. So you can see here we can look at the log files. This is the ORE log file, which you saw previously, and it basically shows you all the outputs the ORE produces, as you'd expect. What these are here, and so on. I'm not entirely sure why we're not interpreting the header line correctly. Oh, we are actually, that's why I said at the top. But anyway, so you can see this is ORE executing and producing an MPV. And these are the curves and so on. Basically, everything you should be used to from ORE. Now, I said I was going to have a quick look. Let me just change my keyboard to English because this is a bit confusing. So what I'll do is I'll very quickly pop over to the external directory, and in there you have ORE. And in the packages, you see here we have two packages. The first package is the input. It's nothing particularly special. I just zipped one of the ORE examples, and you can see the example here, just a normal IRS. This is all data as is per ORE. None of this was generated for ORE Studio. So there's nothing special about this. It's just a regular ORE compressed file. And this is ORE specific. So this is a very, very simple manifest. All it does is it just tells you what you need to do in order to run ORE. It tells you the name of the executable and the parameters. And obviously, the zip also contains the executable, which is, I can't actually do this in inside of a tarball, but if I did a file on this binary, you'd see it's just a normal ELF binary, just like any other ELF binary. So nothing special about it. So presumably, you can put here whatever you like, and the compute doesn't really care. The compute will just take the manifest, unpack all the inputs, and then run it. So there's nothing specific in the compute that ties it to ORE. In fact, we will run other kinds of binaries in the future. And that includes, for example, a binary such as ORE AADC or an AAD for ADLAT. We tried very hard not to bind ourselves too much at the C++ level to ORE. Our interface is just the XML files. So that was an example of running Azure in the compute grid. I think I will just stop right now because I think we've already done quite a lot in this video and it's becoming a bit long. I think we don't really have much more. One thing I probably will mention, it is possible to detach windows if you want. Many people that work on trading floors are used to having very complicated setups. So you can have a single instance of ORE Studio running, and then you can organize your windows however you want. I don't tend to use that very much, but the option is there if you want. And if you want to, I believe, no, actually, I don't think it's possible to reattach all. We did have that feature in the past, but it became very complicated from a Qt perspective, so I removed it because it was very buggy. So now you need to just close the windows again, and once you open the windows, it will again open up as an MDI window within the main window. Okay, so this is all for this video. I will create another video discussing the ORE import itself. Thanks for watching.